For start एक मिनट हाँ
Good morning, friends. So today's episode name is General Relativity. Okay, cameraman. Rima and quantum physics with space time curvature and surface tension. Okay, so suppose like previous episode, I have a three-dimensional physical surface. If we don't have mass, no problem, but if we don't have energy, this space has no meaning. That is no meaning. This space cannot be defined. Okay. But now suppose in this space we have at least energy. We have at least energy. Okay. And suppose energy is located in some region here. Some region here. Here we have energy. And this is outer space where we don't have any energy. Okay. That means this space can be separated from this space which has no mass or no energy. But this space has energy. That means between energized space ES and this is without any energy space, we have a boundary. And this surface actually separates the energized space with the non-energized space. Okay. Now consider zoom in this surface. Now this surface which is continuous. Now of course surface area differentiates from the other physical space which has no energy or mass. But consider this surface. Consider this energized surface. ES. Now this surface can further be differentiated into various small surfaces. Various small surfaces. This is ES. In most simplest way, where inside these surfaces we have energy, and of course outer surface we don't have energy. But here this energized surface can further, when closely look, can further be break down into smaller surfaces. Where inside the surface we have energy and outside we don't have energy. Overall, this is one surface. Inside we have energy and we have some non-energized surface. What I want to say is that in simplest form, energy can be represented by a surface. Okay. Energy can be represented by surface, and inside surface can also be break into smaller surface. That is, in this surface we have smaller surfaces. And under this surface we have energy. Now this surface can further be broken down into what? More surfaces. That means in most simple case and energy can be in this space. Energy can be represented by surface. Okay, where inside surface and outside surface is same. Outside we have no energy, we have no mass. Similarly, inside surface has no energy, no mass. Only surface reflects energy. Surface reflects energy. Now this three-dimensional surface, 3D surface, 3D energy surface can, in simple way, can be formed by a 2D sheet. A 2D sheet. When you give 3D projection, surfaces forms these 3D hollow surfaces. These 3D hollow surfaces are graviton particles, and the simplest form with which 3D graviton particles can be formed by a flat 2D sheet. This is graviton sheet. Okay? Okay, cameraman?
हाँ.
So, energy can best be represented, for example, in deep space by some kind of 3D hollow surface, which is graviton. Okay, in deep space, energy. Okay. Now, for all practical purpose, this 3D surface can be formed by a 2D sheet. When you give 3D projections or vibrations, we get some type of 3D fluctuating graviton particle. Okay, but in deep space. But for all practical purpose, we assume that vibrations are not very much and sheet is flat. Sheet is flat. So in deep space, this 2D graviton 3D particle is actually 2D sheet. We assume so. So in deep space, energy can best be represented by 2D graviton sheet. Okay. So this is deep space. Now this sheet can further be simplified as this single line. This 2D sheet. Okay. So in deep space, suppose we have between A and B, we have one sheet or one graviton particle fluctuation, but we show only one sheet. Okay. But in gravitational field, this same distance AB, due to reversible flow of light, number of sheets increases. Okay, because light as a fluctuation, when light passes reversibly, okay, then these sheets change into curved sheets. So number of sheets can be increased. One sheet, this is one sheet, this is two sheets. So on an average in gravitational field there are n number of sheets. How many? N number of sheets. Now for any sheet, whether it is fluctuating, whether it is flat, okay, whether surface area is same, whether 2D or 3D. Okay. For example, we have this 2D sheet, and suppose we give a light fluctuation here. Okay. A point fluctuation of light enters here. This is inlet. Okay. Then light will cover whole of the surface, and this surface area is fixed. Graviton sheet surface area GSA is fixed. Okay. So ultimately all the energy which comes from inlet as vibration changes the sheet structure, which is flat, changes into something like that. And this is inlet. Okay. And this is outlet. But whole surface area is covered, and to cover whole surface, light takes a time TGS. TGS. Okay? This TGS is fixed because whether it is in flat, for example in gravitational field, we have one sheet. Physical distance is AB in deep space. Deep space, sheet is flat, light enters at one point and outlet is just opposite point. Okay? Inlet here, outlet here. We have one sheet. Okay? Surface area is same. GSA is same. Okay? Time will taken TGS. 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 It is universal time. Newton's universal time. Universal time. Okay? In gravitational field, more number of sheets. Same physical distance, but we have more number of sheets. How many sheets? N number of sheets. But why more sheets? Because sheets are not flat. Sheets are actually curved. Sheets are actually curved due to reversible flow of light because of mass. Okay? But for each sheet, surface area is same. What this surface area is? What this surface area is? GSA. Each sheet surface area is same, and to pass light covers this whole surface, whether it is flat or it is curved. This is equivalent to one surface area of one sheet. Light will take same time. What this time is? TGS. What is? TGS. But clocks. But again, our clock, measurement clock, is based on physical distance. Is based on physical distance. So here, if clock measure it, if this length, if here in deep space where sheet is flat, surface area is same, so time measurement is TGS. What is? TGS. Okay? And now this TGS, if we call this TGN, and this physical distance represents 1 second. What? 1 second. Then 1 second of deep space is equal to 1 TGS. Okay? But when we use same clock in gravitational field, then 1 second, when light travels here from here to here, covering n number of sheets, then 1 second in gravitational field is equal to how much time? N times TGS. N times TGS. Okay? N time TGS. Okay na, cameraman? What I want to say is that graviton sheet, if light as a fluctuation enters here, leaves here, cover surface area GSA. Okay? If light enters here in this direction, inlet will be created here, outlet will be created just opposite direction. Okay? Surface area cover will be same. That is, this sheet behave as some type of circle. Okay? Whether light enter from this direction or this direction or this direction, opposite outlet will be created, and all of the energy which enters here will be collected here, just opposite direction. That is, diameter is same. Diameter is same. Okay? And to cover this diameter, time is same. TGS is same. So length,
Hmm.
length, that is direction in propagation. This physical flat, this seat is flat, for example. Seat may be curved. This is flat seat. This is flat circle. Flat circle from one point to one point. Diameter is same. So time is collected, TGS is same. Okay. So this diameter is actually time. Length and time are equal. Length and time are equal. Now suppose you curve it. In gravitational field between A and B, we have one seat, that is one circle. Okay. Time is what? One dia. T GS, that is in deep space. In deep space, we have one seat. In gravitational field, this flat seat is actually some type of, this seat we change into some type of what? Curved surface, something like that. Okay, something like that. Now flat seat changes into some type of curvature, where flat seat this dimension also shrinks, and flat seat this dimension also shrinks. Okay. Also shrinks. Okay. So light in flat, that is in flat, we have a flat fiber between A and B, and this length is TGS. This is equal to dia. Okay. In deep space we have n number of these flat seats. Why? Because this flat 2D fluid seat has been changed into 3D surface. 3D surface. Okay. Where this dia and perpendicular dia both are shorter than this flat seat. Both are shorter than this flat seat. Okay. Okay. That's why we have more number of 3D graviton particles. Okay. So what it means in terms of space-time diagram? Since our clocks work on physical distance, our clocks works on straight physical distance. So if this length is represented at what? This TGS is actually 1 second in deep space. Now, and in 1 second this length should be, so whether this is length is this characteristic dia, and this length also represents time. So this is TGS. Okay. In this TGS, distance covered is what? This is velocity of light. It is c. Okay. This distance, physical distance is c, and time taken is TGS, which is 1 second. 1 second in what? Deep space. Okay, cameraman. I need some bigger paper, and then now video will be over.
यहाँ पर है।
Now, what it means in space-time diagram. This is physical length light travels, okay, and this is the time taken. But where you will draw this diagram? You will draw this diagram based on measurement. Suppose this region reflects deep space, okay. So as I have shown that in deep space, seat is sometimes circular, okay. This length is actually what? It represents characteristics dia, and it also represents time, TGS. Na? And this is 1 second. This is 1 second. So in deep space, this time is TGS, and it is equal to 1 second in deep space, okay. What is this length? Actually, we measure this length. This is length also signifies time also, but we don't want to represent it by circle. We represent it by some type of rectangular sheet, okay. So this physical distance covered in TGS time. This is TGS, okay. And the distance covered is what? C. What? It is C. Speed of light. Distance covered is C. Okay. Now lights then comes after passing this distance in flat sheet. Light comes into gravitational field. Light moves into gravitational field. Okay. Now in this gravitational field, sheet is not flat like that. Sheet change into what? This sheet changes into what? This sheet change is not flat, but it changes into, if these two representations are represented sometimes by a straight line, then these sheets in gravitational sheets are curved. That is, if line represents flat surface, then curved sheet will be represented by something like that. Okay. Okay. So, but our clocks works only on what? Our clocks works only on physical distance. On physical distance. Na? So same clock, which is physical distance C, and time is TGS, that is 1 second. Same clock in gravitational field, physical distance will be same. But how light will travel? Not on flat surface. Not on flat surface it will travel in all directions, so that outlet will be just opposite direction. Okay. But it will be on curved surface. Curved surface. So there, that means same physical distance between C, we have n number of sheets. This is equivalent to 1 sheet. Okay. We have n sheets. Okay. Why n sheets? Because light does not move on flat surface, so the physical length is maximum, physical dia is maximum. But light moves not, that is, physical length is maximum on flat surface. But now this flat surface has been changed into some type of curved surface, na? Overall curved surface. That is, this figure has changed into some type of 3D curved surface. Okay. Now what it means? Light will enter here and in 3D surface it will move, so that physical distance will be shorter. Okay, physical distance will be shorter, but this length is represented by this. But it covers the area of this half sphere. Okay, semi sphere. But the surface area of this semi sphere is exactly equal to what? Flat sheet of 2D flat sheet of this circular plate. Okay. Okay, that means what it means is that light will be moving in a curvature. Okay, curved. When light moves on a flat surface, but here it moves on a curved surface, in 3D curved surface. But physical length will be decreased. Physical length will be decreased. Okay. For measurement purposes, when the clock will measure the same physical distance, so corresponding to this length, this time will be 1 second in gravitational field. Okay, it is 1 second, cameraman Rima, in gravitational field. But in this 1 second, how many sheets have been covered? Cameraman. N sheets, huh? And to cover one sheet, how much time taken? It is 2, because surface area is same, na? So here 1 second in gravitational field equal to n times TGS. Okay. Okay, cameraman. Okay, cameraman. So 1 second physical distance is same. The speed of light comes on measurement same, c. Okay. But in 1 second, how much area, how much time taken corresponding to deep space? And TGS. Okay. And how many sheets covered? N sheets. How much sheets? N sheets. Na? So how much physical distance covered corresponding to deep space? It is n multiplied by physical distance d in deep space. Na? So physical distance in deep space NC. Okay. Divided by total time. Here 1 second of gravitational field equal to n times TG. N times TGS. Okay. Speed of light will be same. Speed of light will be same. That means, and that's why we got a same speed of light in every frame of reference. Okay. What it means for quantum physics is that between A and B in deep space, it travels in a straight line. Okay. But in gravitational field, light travels in a zigzag path. Okay. That is, we don't have enough pages. This is the state of affairs. What it means is that energy is represented by a 2D sheet. Energy is represented by 2D sheet. time one dimension can be represented, or best way to represent energy is by a circular sheet. Circular sheet. So that dia represent time Tg or universal time, or this length it also represent the universal dia. So time, space and time is same thing. Is same thing. Okay. And if this is same thing, then this circle can be represented by some type of square also. Okay. Where one length is proportional to time and one length is proportional to physical distance. Physical distance. Okay. What it means is that when we draw a space-time diagram, then in deep space we have a fabric which is TGS, okay, and we have a length C, okay. This is our flat sheet, okay, equivalent to this circular sheet, okay. What happens next in gravitational field? In gravitational field, this sheet, okay, this sheet curved. This sheet not flat, but it changed into a semi-hemisphere. Yeah, hemisphere. It's changed into hemisphere. If this represent a flat plate, then it will, in gravitational field, it will be represented by what? It will be represented by some type of curved on both sides, so that this length decreases, and time also decreases, so that it is curved. It is this length will change. That is, up to this point we have measured this distance. In one TGS we have covered this physical distance. Okay, but after that it is curved. That means now this figure is curved. Thus this rectangle has been above the surface. That is, we have a flat surface representing this. Okay. Now this surface changes into a hemisphere. Now this flat surface is represented by hemisphere, this flat part. But this flat part has a smaller dia. That is, we have to, this is curved, so we have to take a projection. So next line, the projection, when we take when light covers this distance, we have to take the projection. Projection will be smaller. Lesser distance. Similarly, this distance, if one side represent length projection, then other side represent time projection. Time projection will be also smaller. time projection will be also example. If this length is TGS, this is 1 second in deep space, then it will be after one sheet is covered, one curved surface is covered, then real time measured in gravitational field will be 1 second of 1 second. That is, it will measure same TGS, but it will be 1 second in gravitational field. 1 second in gravitational field divided by n. So this distance, smaller distance, will be 1 second of gravitational field measured divided by n. It will be represented by smaller length, okay, of time. And similarly, if this length is c, this length will be projection of that. And this projection will be represented by what? How much? C by n. Okay. So measured time is 1 second of gravitational field divided by n, and physical distance is traveled by the light because it is moving in curved surface, so lesser physical distance c by n. So speed of light will be calculated in gravitational field is c by n divided by 1 second in gravitational field divided by n, and then cancelled out, and speed of light will be same. What it means is that on flat surface, okay, if light starts from here, it will be move on flat surface. So straight, we show it by straight line. Okay. But in gravitational field, surface changes into something like that. Now it is curved. Sheet is curved. That is, sheet is curved means sheet is curved. Okay. So light will not move in flat, but it will move in a curved surface, in 3D curved surface. In light moves in a flat surface in deep space, but in gravitational field it will move in 3D curved surface. Okay. What is this length? It is c by n. And what is time? It is 1 second in gravitational field divided by n, because we have n number of sheets. Because if in same physical distance, if this is one sheet, we have n such sheets. Okay. That is.
Okay. तो सब्जी चल रही है.
1 minute.
सब्जी चल जाएगी.
1 minute. Space-time fabric, that is, energy can best be represented by whether in deep space or in gravitational field. Energy is actually represented by a 3D graviton particle. And in deep space it can be flat speed, because vibrations are minimum. It can be visualized minimum flat. But in gravitational field, and the equivalent figure is one straight line. In gravitational field, we have n sheets, equivalent sheets. That is, each particles now have more fluctuations. That is, each sheet has more curvature, more zigzag path. Or in deep space, curvature is minimum, represented by a straight line between A and B. But in gravitational field, sheets are more, so curvature is more number of sheets. This is one sheet, this is two sheets, n sheets. Equivalently, we can say here curvature is more. Okay. Curvature of one sheet is more. Curvature of one sheet is less. More higher gravitational field, this curvature will be sheet will be or more smaller, curvature will be more. Okay, more higher, sheet will be more smaller, curvature will be still more. Okay, but near black hole event horizon, sheets will close. Okay, light as a fluctuation will travel. At the end, inlet and outlet points will be same, and light will form what? Massless particles. Higgs massless particles. Okay. Now Higgs massless particles when coalesce, as in previous episode, gives the property of mass. Thank you, cameraman Bhima.
Thank you. Sabji, पकड़.
Don't. Dr. Jitendra Kumar Singh sir is watching. Thank you, sir. Thank you very much. And what I want to say is that space-time fabric is actually a real fabric in space, because energy, if space has energy, if any space has energy, then the simplest way that energy can be represented in space by some type of a hollow 3D surface. And in gravitational field, these hollow 3D surfaces and any 3D surface can be made by a 2D flat sheet. 2D flat sheet or 2D flat circular plate. 2D circular plate of any fixed dia. That dia length is actually a universal time length, and it is related to the property of sheet. And sheet has a special property, and this property is universal, and this sheet has universal area, and this sheet has a universal physical dia. So this dia in length, it can represent a physical distance, and to cover this physical distance, then that physical distance itself is actually also represent time. So in space-time diagram, if one axis represent movement in space, cameraman marker उठा दो भैया. If we draw a space-time diagram, time and space are same thing. Our clocks works on physical distance between 2 points. But physical distance, light doesn't move on on flat surface in gravitational field. Light moves in a 3D. But our time measurement works on a physical distance, straight path. Time measurement is based on physical distance, straight path, not on the 3D surface. So if we assume that surface is flat in deep space, which is not, but we assume that it is flat, and we assume that it is a flat circular plate of uniform dia, then this uniform circular plate can also be represented by some type of rectangular flat sheet, where one length represents physical distance and other length represent time axis. Now this is our fabric, mathematical fabric, but this mathematical fabric is actually a reality in deep space. It is a 3D hollow surface. 3D hollow surface. So that is space-time mathematical surface is actually a 3D hollow surface in deep space. Number of sheets increase in the gravitational field because reversible flow of light from the gravitational field to the mass and mass to the gravitational field, 3D surfaces fluctuates more, so that physical distance decreases in gravitational field, but surface area is same. So although physical distance decreases in gravitational field, time taken to cover the whole surface is same. But since our clock in gravitational field works on the principle of physical distance, that means since we have more number of particles or equivalent more number of sheets, so physical distance covered is less. But at the same time, since physical distance is same whether it is in deep space or in gravitational field, clock is same. That means time we measured to cover one graviton particle is also less, and physical distance covered by one graviton particle is also less. So when we divide, speed of light is also same. So space-time fabric actually represent what? Space-time fabric, if we assume that it is flat, mathematically flat, but it is not mathematically flat, but in reality it is not flat, but if we assume it is mathematically flat, then in gravitational field it is curved. Sheet is curved. Okay, sheet is curved, and that curved sheet is actually flat sheet or curved sheet. They both represent a 3D hollow surface. 3D hollow surface in deep space or one graviton particle in deep space covers more physical distance, but surface area is same. So more physical distance, but to cover more physical distance means surface area is same, so time covered is same. But in gravitational field, more fluctuation in graviton particle, that is particles to cover the whole surface area particle is same whether in deep space or in gravitational field. Surface area covered is same, but physical distance becomes less. But since clock works on the principle of physical distance, that means measurement of time also shortens out, so the ratio is same. So space-time, mathematical space-time actually signifies a real fabric, 3D fabric in space. But 3D fabric is more fluctuating. That is, for example, we have a sari, flat sari, length is more, width is more. But if sari is if that sari or that cloth, that piece of fabric is changed into cloth so that we wear in space, that means length will short because it is surface area is covered in space. Length will be short and width will be short. If one length signifies physical distance and width signifies time, so both will be short. That is, mathematically, fabric which was flat in deep space is now curved, but that curved surface actually is real, and light travels not in a straight line, whether in deep space or in gravitational field. Actually, light travels as an energy on a energy sheet. In deep space, if we assume that fluctuations are minimum, then sheet is flat. Light travels in a flat surface. But in gravitational field, that flat surface is changed into some type of fabric, has been changed into some type of 3D cloth, and light covers this 3D cloth. But the inlet and outlet physical distance is now decreased because sari has 3D, it has to cover a 3D space. So inlet and outlet points looks closer, physical distance looks closer. But clocks works on physical distance. So in gravitational field, time also shortens out. So physical distance shortens out, time also shortens out, so that speed of light is same. But in deep space, cloth is a fabric, flat fabric. So inlet and outlet covers more physical distance. But area is same, so time is same. Time is same. But since although time is same, but physical distance is more, and clock is based on physical distance, so universal time is same to say, since area is same. But now sheet is flat, so more physical distance, time measured is also more, so that speed of light is same. But mathematically, space-time fabric is equivalent to real physical surface, and that physical surface is flat or have very less vibration in deep space, but it has more vibrations or more 3D shape, 3D projections in gravitational space. But surface area is same. Since surface area is same, that means to cover that surface, light covers both the surface, whether it is flat fabric or a 3D cloth. Light will cover both of these areas in same universal time, which is Newton's universal time, Tg. Although our clocks works on physical distance, not on how light actually travels in space, whether in flat 2D sheet or in 3D cloth. Light does not, our clocks do not work according to real flow of energy, that is real flow of time. Light flows on a approximately on a flat surface in deep space, but in a 3D zigzag surface in a gravitational field. But our clocks works on a physical distance, not on a real flow of energy. But actually light covers the same area, whether in 2D graviton sheet or its projection, that is 3D graviton particle in gravitational field. Surface area is same, and to cover same surface area, same universal time it takes. So energy surfaces are real entities, and they have different properties from the outside space, which has no mass and energy, and that energy surfaces have special property, have special physical property, has special physical shape. That is, energy has shape. In deep space, energy is flat circular plate, something like that, closer to that. But in gravitational field, it is something like a 3D fabric. It changes into 3D fabric. But material is same, surface area is same. To cover same surface area, same time it takes. But our measurement problem is that in deep space, flat area means more physical distance. That means more physical distance means more time. This is 1 second. More physical distance. It covers more physical distance. But in gravitational field, it is 3D, less physical distance. But clock is based on physical distance. So it is, for example, we have in deep space we have only flat sheet. That flat sheet will cover clock inlet and outlet A and B. One flat sheet will cover A and B, which is 1 second, one physical distance. But same physical distance in gravitational field will cover more particles. That is, surface areas will be n times. Surface areas will be n times. So total surface covered will be n times corresponding to deep space. In terms of length, it will be n times, n sheets, n flat sheets. So total distance cover n times. But what about time taken? Since n sheet, for one sheet we have one universal time, so time taken will be ntg. So what is speed? N times of physical distance in deep space divided by n times time taken in deep space. Speed of light will be same. Otherwise, since clocks works on same physical distance, equally we can say that to cover one sheet in 3D way, time will be 1 second divided by n. And what is physical distance? It will be c by n. C by n in gravitational field. But in deep space, it will be c. And what is the time taken? It will be 1 second. But energy surfaces are real. That is, space-time fabric, Einstein's space-time fabric is real, and it has real properties. Jai Hind, Jai Bharat, Jai Vishwa. And Ravindra Jadhav sir is also watching. Thanks you, Dr. Jitendra Kumar Singh sir, and also Ravindra Jadhav sir. And since I am seeing both of you sir, of course more persons and more honorable persons are also, more senior, junior persons, respected seniors and loving juniors, and of course in science everybody are equal. So with equal respect and for your great patience, I am leaving at this point. And once again I thank my sister Reema Jaiswal for this video. Thank you sir. Jai Hind, Jai Bharat, Jai Vishwa. Thank you sir.